Good morning, everybody. And, well, we've talked about all these wonderful things that we're going to be able to do with broadcasting. I'm afraid I may be the bearer of a little bit of the bad news part of things. So, but hopefully we'll get through this. But I'm going to try to cover a lot of things here real quick. And if you have any questions, hopefully we'll have a little time for that. Basically, what I'm going to talk about is the situation in the U.S. with respect to spectrum, and particularly television spectrum. There's other spectrum issues in the U.S., but our focus here is broadcasting and mostly television. Okay, back in 2009, the United States Congress asked the Federal Communications Commission, the FCC, to come up with a plan for broadband for the country. So the FCC spent about a year coming up with this, and they delivered a report to Congress called Connecting America, the National Broadband Plan. Okay, in this plan, what they said that there was need for expanded broadband. It was critical to the country's future. They came up with a whole lot of excellent uses, things like more efficient business, commerce operation, improved education, improved health care, better management, on and on and on. Lots of wonderful things you can do if you have all this. The plan touched on wired connections, although an awful lot of what they talked about of all these wonderful things would have probably been better done with wired connections. The whole focus was wireless. And what they said that was needed was that they needed 500 megahertz of new spectrum within 10 years, and they needed 300 megahertz of new spectrum for broadband within 5 years, and it needed to come from spectrum in the range somewhere between 225 megahertz and 3.7 gigahertz. So where was this going to come from? Well, some of it was going to come from some of the existing bands where things weren't being used, but the biggest chunk of this 300 megahertz that they wanted in 5 years was going to come out of the UHF broadcast band. 41% of the band. Okay, so how do they come up with this idea that they needed all this? Well, they extrapolated from the recent growth in wireless. Now, I'm not sure that that was the best way to do this, but this is how they were trying to justify this. My feeling is that, everybody that one of the cell phone has one, and to expand further in data services and everything, I'm not sure people could afford the data plans. But anyway, they decided this is what they needed. And the reason for taking the broadcast spectrum is that they said, well, the spectrum's worth more for wireless than it is for broadcasting. And they said broadcasting was an inefficient use of the spectrum, which I think a lot of us might beg to disagree on that. Anyway, so how they were going to get this, they talked about maybe revising the interference protection requirements. It means you can put stations closer together. Stations, since you have digital now, stations maybe could share a channel, run 2 program streams in one channel. Unfortunately, there's already a lot of stations that are already doing that now, so to share, they'd have to give up something. They also talked about possibly using things like single frequency networks and auctioning spectrum. In other words, basically give broadcasters money to go away. They also talked about doing maybe just a simple repack of the existing band to try and rearrange stations and come up with more spectrum that way. Unfortunately, they did that, and that didn't gain them anything. They got 1 channel out of it. So that didn't help. And then there was also talk of things like spectrum fees. Well, if we can't get you to go away any other way, we'll price you out of business. All right, let's back up a little bit of television spectrum history in the U.S. Back in 1938, we had 19 channels authorized. Now, nobody was really doing anything, but those were the channels. Move forward to 1940. We were down to 18 channels. Part of it went, a lower end went away and went to FM. 1946, that was back again, but we moved FM someplace else. We have down to 13 channels. 1948, We lost channel 1. We now only have 12 channels. So after World War II, there was more demand for spectrum for broadcasting. So the initial response was to try and reduce the spacings, and that resulted in a whole lot of interference. They decided that wasn't a good idea. So in 1952, they added UHF to the television spectrum, and these were channels 14 to 83. With channel 37 was reserved, it could not be used for broadcasting, it was reserved for radio astronomy. Then we started adjusting this. In 1970, they took away channels 70 to 83 and reallocated that to land mobile. Also in 1970, they took channels 14 to 20 and gave those to land mobile in the 10 largest cities. And in 1974, they added 3 additional cities. Theirs was the original cities, although 2 of them, Cleveland and Detroit, were never really used for land mobile because they could never get an agreement with Canada on that, because they're along the border. And these were the additional cities they added. Broadcasting could not operate co-channel within 250 kilometers of those cities and 176 kilometers on the first adjacent channel. So anyway, so here's a little recap of sort of where we were then. In 1953, there was 486 megahertz available. By 1970, we had lost 84 megahertz of that. Plus, in addition to that, the 11 cities were being used, large cities were being used for land mobile. So then we started planning for digital television in the early 1990s. And so we had to have a way of transitioning from analog to digital. So we had to decided that you had to give each of our approximately 1,600 to 1,700 full power television stations an additional channel. And so we had to put those into the existing band. But we still had, the same restrictions. In addition, there's about 6,000 what we call low power television stations and translators. Those were ignored in the digital planning. They were not given second channels, and some of them were even displaced by the digital. So we shared for a while, digital and analog. Each of those analog stations had a digital channel. It essentially replicated the analog service area, although some of the stations that were analog at low VHF, they had a UHF channel, they were not able to replicate it, just took too much power. And interference was a compromise. There was more interference, especially to analog, but there was also interference into the digital, which I believe they could tolerate during the transition. So anyway, we finally transitioned to fully digital for all the full power stations just a few years back. And we shrank the band again. Another 108 megahertz went away, and so now we're down to channels 2 to 51. The stations had a choice. If they were within the 2 to 51 range, they could pick either their analog or digital channel for final operation, and the service contours were comparable to what they had for analog. Part of the problem was that some of those compromises, especially on interference that occurred during the transition, didn't go away, they became permanent. So where are we today? Okay, we've got 49 channels, 294 megahertz of spectrum. We still have these major cities where we've got channels that are being shared with land mobile that are not available. We have approximately 1,800 full power TV stations. Full power TV stations in the US, at least we have operate in 3 bands, low and high VHF and then a UHF. And the UHF stations can have powers up to a megawatt. And we have a good number of them that are running a megawatt, and most of them are, the ones that are less than that are probably maybe half a megawatt. So they're high power. We also have, again, about 6,000 low power TV stations and translators, and UHF, their maximum power is 15 kilowatts. So these are all sort of substantial size facilities. So we've lost 192 megahertz since 1953. Now you also take into consideration that low VHF just doesn't work very well with digital. There's just way too much noise there. So if you take that away, you've really lost about over 50% of your spectrum. So, back to the broadband plan again. We've got 294 megahertz of spectrum altogether. Broadband wants to take away 120 megahertz of that. We got a problem. So, we did a preliminary assessment of this, of what would happen is if the existing stations were still to maintain programming, what would happen? And here's what happens. If you look at this map of the United States, these are TV markets. The ones in blue would require at least some of the stations in the market to share a channel. The markets that are in red would require at least every station in the market to share a channel with another station, and in some cases there would be more than 2-to-1 sharing. Someone would have to, 3 stations would have to share a channel. So it's not a pretty picture. All right, now, so they had this broadband plan, so how do they implement this? Well, they came up, there was an act of Congress, and its official title is the Middle Class Tax Relief and Job Creation Act of 2012. Now, in the United States, we like to take things, and we come up with an act of Congress, and we lump a whole bunch of things into one thing. Part of that was Title VI, Subpart D, which has now become called the Spectrum Act. And so what that did, it authorized the FCC to conduct broadcast spectrum auctions. Now there was to be what was called a reverse auction and then a forward auction. The reverse auction is that the broadcasters could come in, if they wanted to give up their spectrum, they could propose a price. They could bid, put in a bid and says, for this much money, I'll go away. The forward auction, of course, is just a normal auction. Once they get the spectrum back, they'll auction it off for some type of broadband use. Now, one of the important parts of this thing, though, is that the Congress said it had to be voluntary on the part of the broadcasters. If you don't want to participate, you don't have to. And they offered 3 options for participation. You could completely give up your channel and just go away and be compensated for it. You could give up a UHF channel and say you were willing to go to high VHF and operate there. Or you could give up your channel in exchange for sharing a channel with somebody else. And those were the 3 options for participation in the auction. Okay? Those that were eligible to participate in the auction were the full service stations and what's called Class A stations. These are low-power TV stations that have been granted primary status. They can't be displaced. They're basically treated the same as a full-power station. And they're allowed to participate in the auction. Stations that agreed to share a channel or change channels would maintain their carriage rights. This is mainly with cable. In the U.S., the cable companies are required to carry the local stations, and there's different ways you can do that. If the cable company doesn't want to pay you for it, they don't have to pay if you just come in and say, I want you to carry me. Now, the broadcaster has the option of saying, all right, if you want me on your cable system, you have to pay me so much a month. And so a lot of the broadcasters actually derive a considerable amount of revenue just from cable carriage. Also, the stations that would remain after the auction, the fact that we're going to have to try and get contiguous blocks of spectrum, preferably at the upper end of the UHF band, means that some of the stations that would remain would have to be relocated. They could not be forced to change band. If they didn't participate in the auction and they're staying, if they're a UHF station, they have to have another UHF channel. The relocation expenses will be covered out of proceeds from the auction, though there was an upper limit put on that. But the auction has to generate enough money to cover that. In addition, the auction is supposed to show a profit, of which would go in, the proceeds of which would go to build out more public safety communications infrastructure. Okay, so we need contiguous blocks of spectrum. As I said before, that means you're going to have to repack. And the repacking was supposed to be done based on a computer methodology, which the FCC uses now when they're when you're making changes, they proposed changes are analyzed using a methodology which is described in a document called the FCC Bulletin OET 69. We'll talk a little bit more about that. Now, the Act of Congress also said that the Commission had to make all reasonable efforts to preserve the coverage area and population served of these stations that were either changing channel or did not participate in the auction. This is where the Bulletin 69 comes in, or we just refer to it as OET 69. It's actually a document, although the software, really there's a lot more in the software than is in that document. And I know because I wrote the software. Anyway, what it does, it predicts coverage and interference. The core of it is the Longley Rice terrain-dependent propagation model. It establishes contour boundaries for each station, and then it breaks that area within that boundary down into grid cells, and then analyzes whether or not there's predicted service and or interference at each of those grid cells. So anyway, the FCC had to implement this, was trying to implement this thing. So the way the Commission goes about implementing something like this is they do have what they call a Notice of Proposed Rulemaking. And what this is, the Commission lays out what it is they plan to do. Sometimes they lay out options. We could do this or we could do this. And then they request comments on that. And then there's also something called reply comments where people can reply to whatever the other people commented on, or they can reply to their own comments if they like, if they want to throw something else in. And that was adopted last fall in September. So there's a whole lot of issues that were raised in this, and I'll sort of quickly go through some of them. The goal, of course, is to get these contiguous blocks of spectrum that they can auction off. Now, of course, the participants in the auction are likely to be all over the band. So, as I said before, repacking is going to be required if stations decide they don't want to participate and have to get moved. Depending upon the repacking scheme, which is going to have to get paid for, how that repacking gets done affects the cost of it. So they've got to weigh that in analyzing the bids and all of that. They also have to do this service replication, both the area and the population. Now, these terms, coverage area and population served, that were mentioned in the Act, aren't defined in the Act, nor are they defined in OET 69. So here's what the FCC proposed, and this first one is probably not controversial. Decided that the coverage area for full service station would be the area inside its noise limited contour, and this is just limited just by noise. As long as the signal's above the noise threshold, that's where the contour is. For Class A stations, theirs is inside what they're called their protected contour, which is a little higher level than the noise protected contour. And then the other one was the population served, and what they decided on this was that it would be the population inside that contour that's not affected by interference, and also has high enough level to have service. The contour is defined just using a set of curves and the height above average terrain between 2 and 10 miles. That once that's established, we go to this Longley Rice propagation model, which looks at all the cells in there, and they may or may not have service based upon that, because that looks at the terrain path, the entire terrain path between the transmitter and the receive point. So even though it's inside that contour that was initially established, it might not be predicted to have service. Okay, this replication thing. Now, when you change channel, due to the frequency changes, the same antenna doesn't produce necessarily the same service. Especially when you take into consideration this Longley Rice model, which is also not only terrain dependent, but is also frequency dependent. So The FCC has software that will design basically an antenna which will actually replicate exactly what you have now. The problem is that the antenna may not be practical to build. So there's a couple of options with that. The commission said, well, we will let you use your current antenna. You adjust your power so that the total area inside the contour equals the same total area you have now. Now, this may mean that the contour may be further out, some places closer in than others, but as long as you have the same area inside that thing, that's okay. They would also let you use a different antenna pattern, provided that it did not go outside of what the replication pattern would give you. At least that's what they're proposing anyway. Now, some of the problems that we run into with this is that when you start changing channels, you start having a problem with who you're serving, because with the different propagation change with the different frequencies, some of the population is being served, may not be served now. You also are moving stations around, so you may have the same amount of interference you had before, but it may be at a different place. And so those are things that have to be considered as to determine whether that's acceptable or not. The FCC's also decided that, well, we think that maybe we're going to allow more new interference. Now, right now, the current limit is, if a station wants to make a change in their facility, they cannot cause more than 0.5% new interference to any other station. But there's also a baseline a baseline facility on which that was based. And what's happened is that a lot of these stations have already increased powers and things, and they've eaten up this 0.5% already. Well, the commission wants to basically ignore that and say, all right, we're going to allow now another additional up to 2% interference. So why are they going to do that? Well, of course, it makes it easier to get the spectrum they want. Another thing, too, is that they put a cutoff date of what facility would be protected. If you had a construction permit as of the date of the act, or a licensed facility, that would be protected. Anything that was granted after that, that facility will not be protected if it's a different service. And I won't get into it, but there's some unfairness about that, about things that have gotten held up and shouldn't have been. So, but I won't get into that. So there's a couple of ways that you could go about maintaining the population served. You can just do it on raw population and say, okay, if I'm serving 1 million people now, at the end of the day, wherever I land, I've still got to be serving 1 million people. Might not be the same 1 million people. Or you could look at this on a cell-by-cell basis, which would basically be true replication, where you look at each cell and says, well, this one has service, it has to have service after I change. The easiest one to do, of course, is just the raw population, and that's what the FCC wants to do. But it does run the risk of having viewers that no longer have service. You might get some new people, but some you lost. Of course, the cell-by-cell thing is more difficult to do. It gets you the best result as far as replication, but it also may reduce the amount of spectrum that you're able to get back because of the constraints of it. They also proposed some other things for auction participation. They asked whether or not that they should allow stations to move from UHF to low VHF. One of the options was that you can say that I'm willing to move to high VHF, but they didn't mention low. They want to give you that option. Also, just an option to just accept more interference from other TV stations or from broadband, or reduce your power and agree to a smaller service area. Now, of course, part of the problem with this is that they basically all reduce service. And is that really acceptable? This has not been the FCC's policy in the past. If you wanted to change your facility and you were going to, say, significantly reduce power or move your transmitter sites significantly, they took a long, hard look at this as to see who was going to lose service. And if they thought that there was too much service being lost, they wouldn't grant it. Now they're saying, okay, well, maybe that's all right now. We've changed our mind. There's some other issues. What about Channel 37, which has been reserved for radio astronomy, and it's also used by for medical telemetry in a lot of places. The radio astronomy is a receive-only thing, and they're listening to all sorts of things, signals, coming in from space, and they use it for a whole lot of different purposes. Things like, predicting earthquakes and, continental shifts and all this sort of thing that they use some of this data for. There's a concern that, can they use some other frequencies? And they actually do use some other frequencies, but is there something unique to channel 37 that if they couldn't go to another channel and have the same result? And they have facilities that are built specifically for that channel, which would, of course, have to be rebuilt if they move someplace else. The medical telemetry is another thing. It's used in areas where you don't basically have adjacent channel TV stations that would interfere with it, or in those areas, if it does, it's very limited amount of the band of that channel that they're able to use. And there's also a discussion in the Act about relocating these things if it can be done for a certain dollar amount. Now, there's a question about whether or not, there's so many of these things out there that they may not be able to relocate it for that. So anyway, there's a lot of problems with using the channel 37, and it looks like at the moment the FCC sort of appears to be leaning to just leave it alone, and we'll work around that. There's also a lot of concerns about the band plan for the new broadband band. Of course, there's a discussion of talking about having both the reverse auction and the forward auctions at the same time. Well, this is a problem because they really don't know how much spectrum they're going to have to auction off. So, and you're not going to know that until you get the reverse auction completed. So that's a complication. The FCC has proposed for the broadband, for that band, that there would be a uniform nationwide downlink block of frequencies. The uplink frequencies, in other words, from the cell phone or whatever device back, might be variable depending upon how much spectrum they would have in different parts of the country, because they've come to the conclusion that they're likely not to get the same amount of spectrum everywhere. Because there's some places now where there's already spectrum available, in less densely populated areas of the country, there's already spectrum there. And they might have stations in those areas who aren't making any money decide maybe I will go away with pay me. So they know that there's going to be probably a variable amount of spectrum available, but they're going to deal with that on the uplink end. The plans that they've put out there, the band plans, is sort of a mixing television and broadband. Television, broadband. More television, more broadband. Well, most of the wireless carriers look at this, and the broadcasters looked at this, they said, what were you thinking? We probably should stay away from each other as much as possible, so let's not have all these edges we have to worry about. And the FCC still thinks there's a rationale behind that. So there's a big discussion about that. I was just at a panel last week where that was being discussed. And so we'll have to see how that plays out. But that creates additional problems, because then you have to worry about protecting each other at the edges of these bands. It requires larger guard bands in between to avoid interference, and that becomes wasteful of spectrum. So also this potential that you're not going to have the same spectrum available throughout the country. You're going to have the situation where you have broadband and television sharing channels. Now, you can separate them good ways apart, and this works, until you have ducting. And then maybe for several hours, it only occurs every now and then, but for several hours, all of a sudden, these things that were spaced far enough apart aren't spaced far enough apart anymore. So you've got this high-powered television facility out there. That signal's booming in hundreds of miles away, wiping out all your broadband service, maybe for 2 or 3 hours. And it doesn't happen very often, but it's going to happen. It happens now. We've had, with the sharing that we have now with the channels 14 to 20, this happens every now and then, that all of a sudden and a lot of that's used for public safety, and they start screaming that they're getting wiped out with this TV station that's hundreds of miles away from them. So it happens occasionally. And we've already got this problem because they've already auctioned off television channel 52, and you have wireless carriers there, and we're having problems, the interference between them and the TV stations in just both directions. They have a problem with high power from the TV on channel 51. You also have a problem when the handset gets really close to the TV receiver. Now it's putting out a whole lot more power to that receive antenna than the television station is. So we already had that problem. And as I said, you've got different real power disparities. The broadband base stations, tend to be a kilowatt or less. The consumer equipment, the cell phones, typically are 0.2 of a watt or less. Full power TV stations at a megawatt or 15 kilowatts for Class A's. These things just don't mix very well. Experience tells us that there's, can be big problems if you don't do this right. Anyway, so I'll just sort of sum up here really quick. The television broadcasting has already lost a lot of spectrum over the years. It looks like we may wind up losing more, which is going to pose problems for us. We're going to have to figure out how to do at least the same as what we're doing with less spectrum. We've got these band plans that are going to cause problems. But we just don't know at this point because, as I said, this is a rulemaking from the FCC. The rules are not out yet. Now, they have said that they will finalize this by the end of the year. Now, that might not be the end of it yet, though, because the way this usually works is the FCC will finalize something, somebody doesn't like it, and they'll file a petition for reconsideration, which the FCC then has to consider that, and they can just consider it, deny it, and give her, whatever reason they like. And sometimes it doesn't end there because then they deny it, and these parties, if they think they're being, treated unfairly, well, then they will take it to court and they fight a battle there. So this isn't, this may not get finalized this year as to what's going to happen. Now, will any of this really happen? The rules and all that will happen, but will they actually get enough broadcasters to participate in this to get enough spectrum back to make it worthwhile doing it? And my feeling is probably not. They may get a lot of broadcasters to participate, but the price tag they will put on their spectrum probably will be too high. They will get spectrum in the small markets in the areas where there's not a lot of population. They'll get some participation there. That's not where they want spectrum. They want spectrum in the top 10 to 20 TV markets. And those are places I just don't think they're going to get much participation, or at least at a price level that they can afford. So we'll have to see where this goes. That won't be the end of it either, because they'll figure out some new scheme to try and get spectrum. So anyway, that kind of wraps it up. If anybody has any questions, I'd be happy to try and answer them. In the back there.
Thanks for your presentation. I'm Marty Rumley from Untitled Technologies, and I've heard all this story from the side of the cellular operator from the FCC, so it's quite interesting hearing your take on it from the broadcast side.
Right.
There's obviously quite a lot of passion in the message there.
Right.
On the assumption that this reverse option isn't going to be as successful as the FCC think, what do you think the options for the communications industry are?
Well, I think that in the end, I think there's going to have to be some cooperation between the industries. What's sort of interesting that's come out of this is that these wireless carriers who are looking to get this spectrum don't necessarily want to use it the way the FCC thinks they want to use it. What they really want to do is get into broadcasting. One of the major carriers, Verizon in the U.S., has publicly said that. That's what they want to do, is do broadcasting. So you have to think about this. Does this make any sense to take spectrum away from somebody who's doing broadcasting and give it to somebody else to do broadcasting with it, just with a different methodology? Does that make any sense? So I'm just not really sure. This whole thing didn't get thought through really well. My feeling is that, and I think Verizon's right that this is the way they would make money, because I don't think that they can make money with just more, wireless spectrum. The data plans are expensive. I mean, it costs money. It costs a lot of money to build an infrastructure for this. They've got to buy the spectrum at auction, then they have to build a huge infrastructure to support all this. Who's going to pay for service so they can have, a one-to-one connection so they can do video on demand? People can't afford that. The carriers can't make it cheaper because it costs them too much to build it. So I think there's going to have to be a lot of cooperation here and a lot of rethinking on all of this.
What's the amount of money they think that 120 megahertz worth?
I don't know that they've really. It's a big number. Well, they think there's a really big number. What number they're really would get for it probably will be a lot less. I mean, I talked to someone a year or so ago about this, and he didn't, and is fairly knowledgeable about the industry, and he did not think that they would get anywhere near the amount of money they think they're going to get, because he believes that the carriers already are sitting on spectrum that they've bought at previous auctions that they haven't built out yet, and their stockholders are not likely to allow them to spend a whole lot more money to buy more spectrum unless they can get it really cheap.
Interactivity is becoming more important for broadcasters. So are broadcasters in America interested in running their own wireless networks, converting their broadcast networks to wireless networks?
The answer is yes. The ones that really understand where the future is, yes. I mean, the future is not to the television to the home anymore in the U.S. It's to portable mobile devices. That's the future. The homes are being served mainly by cable now, and then a smaller percentage, much smaller percentage of satellite service. But that market, even if you look at depending on whose numbers you look at, it's somewhere maybe under 10% to the best, maybe 20% of the homes are viewing off air, at least on one set or something. But the future is to iPads and cell phones and that sort of thing, and that's where the broadcasters, at least the ones that are knowledgeable and forward thinking, are looking. That there's already discussions about a new television modulation scheme in the U.S. ATSC 3.0, which is not going to be a backward compatible system, is looking towards that. We also have the international FOV-TV initiative, which is looking at sort of a worldwide standard to do the same thing. So that's where the future is, and part of that is a back channel, so that they can this way they really know what people are watching, because this is very important in the U.S. where it's advertiser supported, and so their advertising revenue depends upon how many people are watching. So if they can get this back channel, then they know exactly how many people. They don't have to make estimates like they do now with a small sample.
Hi, Bill. Perhaps you answered the question, but I just want to confirm on your last bullet point. What is your feeling about the number of U.S. broadcasters who would opt for this U.S. auction? Would you say 0% or? No.
There will be some, because there are stations out there that really aren't making any money. That they're in a small market where there's not a lot of population, and there's more TV stations than they need in that market, and they're likely to say, if you'll give me some money, I'm willing to go away. You've also got, we have sort of a mixture of commercial and non-commercial stations in the U.S., and you have some of the markets where the non-commercial stations where you have more than one of them, more than one public broadcasting service, and some of them are owned by colleges or universities, and some of them are not, really are just a money drain on the university or something, and they would probably be willing to just get rid of it. And they'll participate. Now, I don't know what the number's likely to be, but I just don't see many, in larger markets. you know, the commercial stations and even, you know, in the big markets, even the low end guy is still making money. The spectrum's valuable. Why is it, you know, everybody wants it? It's valuable. So I just don't see that that they'll get that many to participate in the markets where they need it or at a price that they'd be willing to pay for it.
This big chunk of spectrum is used to save only 10% of the population. What do you think the US broadcasters need to do to make it more, to justify this?
They need to move forward so that they do get to this bigger audience that they have out there on the portable and mobile devices. I mean, we do have a system now that will do that. There's a part of the ATSC digital television system where you can do mobile and for mobile and handheld, and there are a number of stations. There's probably about somewhere between 10 and 15% of the stations have built out that facility and are actually transmitting that. They're trying to increase that number significantly. There's two different groups in the U.S. that have been promoting this, and one of them is backed by some of the major networks, by NBC and Fox in particular in the U.S. are backing that, and they're promoting it pretty heavily. I don't think it's the best solution because this was sort of an afterthought to the system, and so it works, but it doesn't work nearly as well as it should. And I think that we've got to be looking to the next generation of system, which is coming along fairly quickly. And in fact, I was at a meeting here a few weeks ago where there was FCC people there, and somebody proposed that the commission doesn't have to complete this whole process until 2022, I think. Why don't you delay this until we come up with this new system, and we'll do the whole transition all at one time, because they also expect that the new system will be much more efficient. And so you actually maybe could free up spectrum because it won't take nearly as much spectrum to transmit the same thing that you're doing now. So, but the FCC's reaction, the person that was there, of course, couldn't really say because he's not authorized to do that. But I didn't like the way he answered it. His answer was, don't even ask. You know, it wasn't, well, we could think about that. No, it was just don't ask. So they're being pushed by this, as I say, it always comes down to money. And there's money behind this. And so that's what's driving it.
I would like to invite you to share some comments on the future possibility of convergence of broadcast and communication industry. So basically, I feel the basic assumption here is that, in the future we still have two separate industries. So I'm not sure, is there any regulation barrier to achieve this kind of future convergence?
There are some regulatory barriers which would have to be overcome, but I think that's a whole lot easier to overcome than some of the hurdles that we're trying to do here. And I think that, it will come. I mean, you're going to get to the point where you'll have devices that will do lots of things. You can make your cell phone calls, you can surf the web, or you can watch television on it. And that will come eventually. But you've just got to get all these people together and say, look, guys, you're going to have to participate here, and you're going to have to figure out how to make this work. But it's all doable. It's just going to take time and and the will to do it.
I'd like to say thank Bill for showing such good leadership in initiating this very difficult subject for the whole of the industry, and it's like it's the future. It's one of the key issues in the future of broadcasting, and it'll be a challenge for the future generations of broadcast engineers to do. So I'd like us to give a warm thank you to Bill for making this. Our appreciation, I'd like to give you these two things. Yeah.
Thank you.
Thank you.
Thank you.
Thank you.